once we have this factor, then we can do some synthetic division. So we want to divide this cubic down into something a little bit more reasonable. So what we can do is we use synthetic division now. And now remember, when we do synthetic division, we do the opposite of this. We take the constant, we take the opposite sign of that. So we're going to have 2, set up the L bracket. Now we'll put in all the coefficients. So we're going to have 3, -2, -12, and 8. Make sure they're in order without skipping any powers. We'll drop the 3 down, multiply gives us 6, we add down to give us 4, multiply to get 8, we add down to get -4, we multiply to get -8, and then we add to get 0. So that confirms that the remainder is correct for this evaluation of the polynomial. And then, so what that tells us now, because we're dividing a cubic by a binomial of degree 1, then the powers of the cubic, or the degree 3 polynomial, are all going to be reduced by 1. Okay? So then p of x then becomes x minus 2, and then these are the coefficients of the new quadratic function that we're going to have. 3x squared minus 4x, plus 4x minus 4. Okay, so now we have a binomial, or sorry, a quadratic, and we know how to factor quadratics from past practice. So now we can factor that however you wish. Let's try maybe sum of cross products. So 3x times x will give us 3x squared, and I don't know, will -2 times 2 give us, -2 times 2 gives us -4. Let's see about the sum of cross products here. So we got 6x, and here's -2x, so that was convenient. And then we add this, we got 4x, and so we see that that 4x matches the middle term, which means that these are the factors of this quadratic. So then, therefore, p of x equals x minus 2 times 3x minus 2 times x plus 2. Okay? So now once we have this factored, then what we're going to do with this later is we're going to graph this. So it might not be bad practice to say, okay, well then the zeros are x equals -2. That would be 2/3 and positive 2. So once you get the zeros, then you can graph the zeros. We see that the lead coefficient of this is positive. It's a degree 3. So it's generally, the polynomial, the graph of it is generally going to be increasing from left to right, and then you can just draw your graph from this information. Okay, so we've got one other example here. So what I'd like you to do is, we got two other examples. One more example where we're going to be factoring. So what I'd like you to do is do this complete process here that we've just seen, but now this x to the power 4, you're going to have to find a factor, then you're going to state the factor, you have to synthetic divide, then you're going to have to state what that new polynomial will look like with the binomial factor, then you're going to have a cubic here, then you're going to have to find the factor again, just like this first, the factor theorem. Use the factor theorem again. Then you're going to have to synthetic divide again. So then when you state the polynomial at that stage, after the second time you've synthetically divided, then you'll have two binomials, and then you'll have a quadratic, which you can then either use decomposition or the sum of cross products to factor completely, and then you'll end up getting a polynomial with 4 factors, and you get 4 zeros. So that will enable you to graph the function accurately. Okay, so please go ahead and work on this, and I will reveal that the results in a minute after you have unpaused the video. Okay, so now that you've had a chance to go through this question here, let's take a little look. So we let p of x equal this polynomial, and then what we're going to do is start substituting in values to see if we get the remainder of 0, which would be then give us the factor of that polynomial. So we substitute in 1, we work that out, we get negative 60, which is not 0. Then if we substitute negative 1, we work that out. Actually, we do get 0. So if it's negative 1 that works, then that means that x plus 1 is a factor of p of x. Then what we'll do is we'll take that negative 1 and we use that for the synthetic division, put in all the coefficients of the polynomial, and we work out the synthetic division, and again we get a remainder of 0 here, so that works out perfectly. So therefore p of x is x plus 1, which is the factor, multiplied by the quotient, which is x cubed 3x squared minus 10x minus 24. So now what we're going to do is do the same thing over again. Start out with this part. So I'm going to let r of x equal this polynomial here, and then start substituting in values. R of 1 in for here, we get negative 30, which is not 0. R of negative 1 is negative 12, which is not 0. R of 2 gives us negative 24, which is not 0. R of negative 2 ends up giving us 0. So that means that x plus 2 is a factor of r of x. Okay, because we use negative 2 in for the values of x for the polynomial r of x. Therefore, we use the opposite sign, which means that x plus 2 is a factor. So then we use x plus 2, well, we take the negative 2, and we use synthetic division for the coefficients of r of x. And with our synthetic division, plug in the coefficients, and then we just work through that, and we get 1, 1, negative 12, and 0, which is good. Therefore, p of x, the original polynomial, is x plus 1, which is the original factor that we found earlier, times x plus 2, which is the factor we just found now, times x squared plus x minus 12, which comes from the quotient of this synthetic division. Then we just have to factor this, which then gives us x plus 1, x plus 2, x plus 4, x minus 3. So the x plus 4, x minus 3 are the factors of x squared plus x minus 12. And from all these factors, then we get the zeros, which are negative 4, negative 2, negative 1, and 3. So once we get those zeros, then we have a chance to graph or sketch the graph accurately. Okay, so now the last example, we now have a bit of a thinking question here. So if ax cubed minus x squared plus 2x plus b is divided by x minus 1, the remainder is 10. So that means that when 1 is substituted, so we take the opposite sign, 1 is substituted in for x, and we work that out, we're going to get 10. So let's go a 1 cubed minus 1 squared plus 2 times 1 plus b equals 10. So then we work all this out, so we get 1 cubed times a is just a plus b, so we have a plus b. And then we've got 2 minus 1, which is just 1. We subtract 1 from both sides, so we get a plus b is 9. So that's equation number 1.